Good afternoon, everyone. My name is Desmond Martin. I'm the Chief Learning Officer at NextWaveSTEM. It is my pleasure once again to welcome you to another one of NextWaveSTEM's webinar series. Over the course of the last year with the onset of the global pandemic, the NextWaveSTEM has been really intentional in reaching out to all of our partner communities in this opportunity for us to dialogue, to share some best practices in teaching, to do a little bit of exposure in emerging technologies and talk about what some of those next steps are for your students as they continue to grow and learn. And as you seek the cutting edge for what your students are going to be learning in emerging technologies. I'm super excited today because this webinar is a little bit different than what we've done in the past. We've been really focused on hard hands-on technology, drones, 3D printing, and also robotics. Today, I'm so excited to have our guest, Marina Malaguti, to speak to us about artificial intelligence and the next frontier of elementary and high school computer science learning. We will get a chance to learn a little bit more about Marina, but we are so glad to have her. Just before we begin, I will cover a little bit of the house rules. We are in webinar mode. That means as beautiful as your voices are, we know that you are absolutely camera ready. However, we won't be able to see your face or hear your voice. That does not mean you are voiceless, however. The Q&A functionality is open and so is the chat. That means that if you have any questions, any commentary, any funny stories or jokes that you would like to share with us, you can absolutely throw that in the chat and we'll address those either live on air or in our Q&A section at the end. One other thing that I want to do before we press forward is ask for us to get to know ourselves a little bit better in the chat. So if you could do me a favor and in the chat, drop in where you're from and what level of education you teach, what you're teaching. That's going to help Marina tailor our conversation as we talk today. Thanks so much, everyone, for that. And with all that being said, we will press forward. We have two main goals today, and there is a typo here, but the goals are still applicable. We'll be exploring ways to conduct artificial intelligence education, really focusing on that next order of computer science. Then we'll also analyze some career pathways with regard to first steps in artificial intelligence. Really excited about that and really expanding beyond our horizons in NextWaveSTEM and for your students. So I'll begin a little bit with doing an introduction for us who may not be familiar with NextWaveSTEM. I'm seeing some familiar faces. Hi, Kathy. Hey, Ms. Ovetta. So glad to have you with us. But for those of us who are new to NextWaveSTEM webinars, at our core, NextWaveSTEM is a STEM education company that is focused on emerging technologies. We think that it is critical that young students who may not have had exposure to emerging tech like 3D printing, artificial intelligence, robotics, and drones get the chance to get hands-on at the ground level. That's really important for what we do because we believe that those young people are going to become the problem solvers of the future. They will literally save the world as long as we can empower them and give them the tools and resources that they need. And at NextWaveSTEM, we do that by empowering you as educators. We want to make sure that you have the tools for today to teach the students and future problem solvers of tomorrow. And we focus on three particular technology tracks. I say it a lot and you'll hear it again later on: robotics and artificial intelligence, drones, and 3D technologies. But we'll learn more about that. With all that being said, I want to take this moment to introduce our speaker for today, Marina Malaguti, who is the host of the UNBOSSED podcast. But she's just not a media maven. The podcast is amazing. If you haven't heard it, I highly encourage you to check it out. And we'll be linking to the podcast in our slides today, as well as in the follow-up email. She is a software leader with a product-first mindset that leverages her innovation-shaped technology, product, and strategy in complex tech markets. Having set a career path for herself in data, she's worked on creating smart and nimble data products for her roles at various companies, some companies that you have definitely heard of, that utilize modern technologies to deliver value for the business and customer. As a data engineering manager for the Instagram Core Ads team, and previously as director of engineering and product data at Jellyvision, she leads teams of data engineers and data scientists, consistently producing results and innovative solutions. She has exceptional managerial skills, and beyond crafting high-performing, happy teams, she has adeptly handled layoffs and performance reviews and issues even through the current recession, and on top of the current pandemic. Marina lives in Chicago with her family and seeks to continue shaping the future of the next company and her community through spirited leadership and software support, software engineering, innovation, and data science, but most importantly, by continuing to support inclusion in diversity efforts. Marina is a big advocate of having more women in tech and demonstrated her commitment by partnering with formerly ITA, but now 1871, in the creation of the Women Influence Chicago Accelerator Program, creating the UNBOSSED podcast, in which she is interviewing prominent women in tech in Chicago. Marina, thank you so much for joining us today. I've read a lot and said a lot, but I want to open the floor up to you.
Thank you so much for having me. It's a pleasure talking to all of you today.
Excellent. Thank you so much, Marina, for being with us. I, in contrast, am Desmond Martin, once again, Chief Learning Officer at NextWaveSTEM. 2+ years now in our 3-year-old startup, with 10 years of teaching in educational technology supplementation. I am NextWaveSTEM's lead curriculum designer and developer, managing our product team, as well as lending some subject matter expertise. My formal background is in mechanical engineering, and it's also my very great pleasure to be with you. I'll be our host and moderator as Marina lends her technical expertise. So I just want to go ahead and dive right into it, and we want to begin with this overarching thought of what is artificial intelligence. It's a turn of phrase that we've heard a lot for the past couple of decades, but we may have a very, if I may say, science fiction definition for what artificial intelligence is. Mm-hmm. Well, before we talk about artificial intelligence, it's really useful for us to dig into a little bit of computer science history. Many of us who are learning computer science and learning how to code and build applications aren't really thinking about the work that started at the beginning and how we've grown in our understanding of computer science and how it shapes the world around us. Once upon a time being back in the 40s, 50s, and 60s, computer scientists were working in machine inputs, really giving instructions to machines to do the most basic of things, holding data in memory, and then being able to do computational work. We grew from there into operator languages. Some of these operator languages are still around with us, like C++, Swift, and Visual Basic. Programmers are able to streamline and automate more computational functions and build more powerful applications, including finally moving into some user interfaces and user experiences that make really good sense. We grew once again into now object-oriented languages, where we can define our processes and functions in really robust and easy ways. Ruby, Python, and MATLAB, some of the processes and languages that we're teaching today are object-oriented, but now we're on this new precipice of artificial intelligence, where machines are using data. Some of us have heard the terms data mining and big data to build their own instructions, to write their own algorithms. So when you hear about students using TensorFlow or OpenCV or even Amazon's recognition platform, we are really on this next frontier of learning how to compute and even computing in ways that we don't fully understand as users. So we think about artificial intelligence as also being defined as machine intelligence, which is quite simply an intelligence demonstrated by machines. And machine intelligence is really a loaded, really heavy phrase, because if you ask to define intelligence, traditional intelligence, there is a field of study or multiple disciplines of study that go back thousands of years trying to quantify this idea of what is intelligence, what makes something intelligent, and how can we demonstrate intelligence in different ways. AI is also divided and has these really amazing gray lines in between different disciplines, where we think about cybernetics, the study of how to govern and self-regulate both in animals and machines. Or we think about deep learning, the ability to build multiple layers of processes, millions, billions, orders of magnitude of these different layers between the input and the output, or machine learning, or even robotics, something that we're really, really passionate at NextWaveSTEM, giving these machines the ability to locate themselves in the world around them in our actual space and move. The overarching idea of artificial intelligence really encapsulates all of these ideas, and we're seeing constantly new applications and new developments along these fields. It is honestly quite mind-boggling to keep up with on a day-to-day basis. So when we think about artificial intelligence applications, the way that AI is used around us every day, we're thinking about weak AI. And weak is a very relative term, but used in applications that we see every day and that we often don't even think about. Machines are giving us guidance, and even in some situations, in many situations, automatically investing in trading, that's what I should say, investing in trading financial tools and instruments, many orders of magnitude per second each and every day. We hear about cybersecurity and the use of artificial intelligence in securing our data in military applications. HR, manufacturing, and I focus on manufacturing because of this idea of generative design, giving constraints to a machine and the machine actually designing an object to be built all by itself. No human input, no drawing. Here are our hard points. Here's your material. Make something that is as strong as we need to be with the lightest amount of material. The machine will do that for us. Marina can really speak to the way that we use artificial intelligence in marketing, especially with the rise of globalization, the internet as we know it, and the internet that we don't know. In media and e-commerce, I highlight deep fakes now because we think about data being used in some really interesting ways and even ethically dubious ways. But also in transportation. We're going to be seeing in the next couple of decades autonomous flight and autonomous driving, which is in a lot of ways already here, begin to reshape our landscape, really start to change our infrastructure and the way that we move goods and services and people from point A to point B. This list is by no means even close to exhaustive. But this is just to give you a little bit of a hint of all these different spaces and ways in which AI is becoming intertwined in not just your life, but in the lives of your students. So now that I've spoken a whole lot, I kind of want to turn things over a little bit and get some input now from our expert. And we'll just begin with some questions that are interesting from this experience of a professional. So the first thing I want to ask, Marina, is how do you perceive the growth opportunities for students who are in career and technical education pathways, was once colloquially and even now still called vocational tech, VOTech, in artificial intelligence, computer science, data science, and even adjacent industries. If I'm a student who's in high school looking to advance into a career, what are my options out there? And what's the real growth factor?
Yeah, that's a really good question. And there's a lot of opportunity financially wise, and also like in terms of absolute number of the need for individuals that can work with artificial intelligence, computer science, data science, and software engineering in general. The sheer number of not only like jobs in the market, even during the recession, as well as the financial payoff and the flexibility that some of these careers give individuals. I'm totally biased, but to me, it's definitely like one of the greatest industries right now. In terms of growth opportunities for students, in our industry, we actually say that there's all jobs now are tech jobs. The reason why we say that is because most humans now have to deal with a computer in order to do their jobs, whether even if it's a grocery store, checking out people, or if it's sitting at our computer on a Zoom call for X amount of hours a day. And really, computer science should be perceived as one of those basic sciences that should be taught in school, just as it is like, biology or something like that. Is so intrinsic to our everyday life that it should be really something that everyone should understand, at least on a base level. The reason why I say that is because beyond that, I view the opportunities in two buckets. One is the bucket of people that create the software or create the hardware, create the artificial intelligence. And two are the people that use and apply those technologies in order to improve a sector. And why are both needed? The knowledge required in order to create nowadays a solid algorithm that can go out and actually produce something is quite large. And so it takes a whole career in order to build that on its own. But we also need the specialists on the field that deeply understand what's happening at the local level in order to apply this intelligence in each and every sector. So both roles are needed, and both roles require different training and education, but both really need to understand what is computer science, what is data science, how do you use it, how do you apply it, and how you make it happen.
That's really interesting to hear you talking about the way that the data scientists and the data miner are really refining and building these extremely robust skills that will then work with your programmer or your machinist in some situations to build a final product. Making that big distinction between one who might just be the consumer of technologies and one who is the producer, who can, for lack of a better word, go underneath the hood and understand what's happening, is something critical when we think about the future of work. I want to dig a little bit more into this idea of working and building a career in data. We hear all the time, especially in the e-commerce space and the advertising space, how important big data is. The ability to access, to mine, to scrape, to process and understand these enormous data sets that might be changing constantly. Do you perceive in your experience that your average student, one, understands how big data actually is? And two, do you think that's just a common misperception of the way that we're going to continue to build using data?
So there's absolutely no way to humanly understand how big data can be. Even at my current job, in which we have about 3 billion people, and we have billions of interactions per hour. It's even for me hard to perceive how much that really is, like physically with my brain. The reason is because big data, and let me add, big data is only as useful as how much good data you have. So if you are collecting a bunch of junk data and you're collecting a lot of it, it doesn't matter. It's not going to help you. So that's why it's so important to have people that know what to collect and how to use what you're collecting. And I think we're going to talk later about the responsibility of and the implication of collecting data. But if we think about it, big data is going to be part of our future no matter what. There's going to be definitely privacy implication and security implication that's going to happen. But the need to collect this information is useful. It seems to be useful for all individuals. So to answer your question, I think I don't think people can comprehend how big data is.
You know what? I appreciate that answer. I have studied many marketers and professionals that if we think of a platform just like just saying YouTube, for example, and if we had to calculate how many pixels have ever been uploaded for YouTube for the tens of thousands of years, probably more than that of content that has ever been uploaded on a program on that platform that's less than 2 decades old. It's a number that we can't consider. It's many, many multiple times more than the numbers of stars that we've ever seen in the known universe. This data is tremendous, and that's just one streaming platform living on all over the internet, but just one platform. We're not even talking about a Netflix or an Amazon video or any other video platform. The sheer staggering amount of information that we have to work with and the opportunities that presents is exciting, but it's kind of hard to grasp. So putting it down to our human level is a continual challenge, definitely.
Absolutely. And just to give perhaps an example, in a 10,000 company employees, if everybody were to collect their laptops at Instagram or Instagram, Facebook, and use all of their laptops to comb through the data we have, it wouldn't be sufficient. We definitely need to put that in the cloud, in virtual space, and use virtual machines to analyze data. Which
is, of course, absolutely necessary, but also thinking of our students presents this other growth opportunity. The ability to work in infrastructure in the front end and back end of these experiences is extremely important.
Yeah.
That's amazing to think about. What I wanted to do now is turn tack just slightly to think about pipeline and even our expectations here. You in your various roles have managed teams of engineers, of data professionals, of data scientists to build experiences for clients and companies alike. And I'm thinking about the composition of your team, thinking about the way that you got to learn your team and even your roles in recruitment and helping career advancement. Would you say from your own experiences, so the things that you've learned about the people who work in the data industry and in artificial intelligence, that there's a lack of participation in the US in the middle school and high school levels in data science, in artificial intelligence, that helps explain some of the persistent lack of STEM professionals amongst higher ranks. We hear constantly, every quarterly news cycle, that the United States is not producing enough STEM professionals. Is that what you're seeing as well?
Yeah, I think there's a couple of things there that I can highlight based on my experience and what I've studied the education here in the US and in Europe, because I am from Europe, right? So I can speak a little bit to that. But if we think about it and we look back, Desmond, at your graph, when we started with the most basic level of math and engineering, right? If you go back to that graph. Yeah, one more, I think, right there. Okay, when we were talking about machine inputs, which was probably, I don't know, back in the 80s or something like that, all you needed really in order to get that job done was a basic understanding of math. That's it. So what happens is that actually women participation in the field was about 40%. Nowadays, I just want to highlight, is less than 20%. Because all you needed is really to be able to do some pretty general calculations. Calculus level math would have been sufficient for this type of machine input roles or jobs in the market. As we moved up the ladder and we made this field more complex, one, it became an engineering field when in reality it started just as a math and algorithm field. Not everyone wants to be an engineer. Not everybody has the support, familiar support, or has the understanding of, knowing what engineering is in general. And so kind of like it got isolated into its own echo chamber, if you will. So becoming an engineering field and becoming more and more complex, the level of knowledge required in order to enter these fields, it became increasingly higher. So like that's why we hear a lot about the kid that started coding at 12 years old and now it's a millionaire, or the kid, that you need, in order to be a Mark Zuckerberg, you need to start coding at the age of 9 or 8. Is because there's this change that happened in the industry, that as it became more complex, the level of the education needed in order to enter the field, it became higher. And not everybody in the market, one, is aware, and two, has access to this type of education. So I would say, yes, the participation of students in this type of industries or in this type of education even, it's absolutely necessary to enter the field. Now, what is not necessary is knowing how to do it necessarily, but knowing that it exists is just a great first step. Knowing that you could be a computer scientist, knowing that you can problem solve using machines, I've seen that is just a great first step in order to actually be able to enter the field and be motivated to learn what others have been doing already for the past few years of their lives. Let's go back to that question. So in order to, perfect. In Europe, just to give you a contrast, there are, most high school actually have some type of technical specialization that requires all students to take some type of coding class. And this could be like very basic level, like .NET, something like super easy, that introduces everyone into the area of coding. And so I think is definitely the lack of knowing that this could be a career for people is definitely one of the reasons why there is a lack of STEM professionals. Another thing that I found out during my podcast is that usually there's always an actor of somebody that has pushed an individual into the field or introduced an individual into the field. So as educators, I encourage, I guess, all of you to introduce all of your students into the STEM fields, regardless of whether they seem prepared enough, if you will, to be able to succeed in them, because that introduction has propelled many individuals into actually being very successful in the field of STEM technologies. The third thing I would say that is definitely very relevant for Chicago and kids that perhaps do not plan to go to college is that development boot camps do not require a college degree in order to attend, to be an attendant or to be a student. It is a great replacement, if you will, for going to college and potentially serving those kids that are needing to make an income earlier in their life versus later. So said in other words, like the way I see it is like not everybody, one, wants to go to college, or two, has the capacity or the financial means to go to college, given how expensive this is. So not everybody can actually get a computer science degree and has the the luxury to spend 4 years studying. So I would say like a 2-year, 12 months or something like that dev bootcamp is a great solution for those students that cannot wait, that need to work because they have families that they need to help, or they are in neighborhoods in which they perhaps don't have the same opportunities as other people. And so making those students aware of this type of opportunities and letting them know that they have options, I think is a great way of making sure that we increase the number of STEM professionals in the field. And I don't know if you all knew this, but Google has recently removed the requirement of a college degree in order to actually apply for any of their jobs. Other companies like Facebook, Instagram, and Twitter are following the same suit because we realize that in order to be a great developer, you don't necessarily need a college degree. So it's very important that we make all of our students aware that there are options that do not require, the traditional path of engineering in order to achieve these professions.
That is extremely compelling, to think about the way that the very traditional primary, secondary, university pathway that students are taking is maybe not going to be the future when you think about STEM forward fields. And I think that you're saying something really powerful when you think about the lack of exposure, or even the lack of proper mentorship to really move and engage into these spaces. Something that we talk about a lot at NextWaveSTEM is this idea of STEM identity, students seeing themselves in these fields and able to interact with other professionals, professionals like you, Marina, who are able to also give them a window into the field. That idea of the windows and mirror paradigm for engagement. So when I hear and when we see these new pathways and new opportunities that are not traditional and frankly don't create so many burdens and barriers for students to engage in STEM disciplines, that becomes a really, really exciting prospect.
Absolutely.
So I kind of want to make one more turn, another facet here, and think about assessment. Because as educators and as team leaders and motivators, something that we all need to do is actually assess our students. We have to be able to measure how much they are learning and how many skills they're acquiring, and their ability to apply these skills to solve problems that they haven't seen yet. It's actually funny because if we think about predictive modeling and artificial intelligence, we've got a little bit of that same thing going on. We want to be able to know that our subject is going to be able to solve a problem and even make some predictions about what to do in an unknown situation. If we think about artificial intelligence, what kind of assessment would you make for your team member as to their growth, as to their efficacy? And do you think that the way that we assess professionals in the artificial intelligence and data science field matches the way that students are assessed in their educational pathways, even through the university level? Do you see those things matching up, or is there a disconnect?
Yeah, like I said, there's definitely a disconnect, right? Just the fact that we don't require any more college degree in order to enter the field means that there's something there that is not right? Like there's the training required are almost done on the job. Obviously, you need a certain level of education in order definitely to enter the role, right? But there's definitely a lot that is done on the job. Let me go back in terms of like assessment and using artificial intelligence in order to assess students or to assess professionals. The way I think about even my professional as a manager, the way I do things, and I hope this translates to educators as well, is like I think about the curriculum or what my team needs to learn. I think about the learning experience, and then I think about then the assessment of the learning experience. So I actually was part of a group called Learn Anything.xyz, And it's this group that of developers and I that put together this super simple website where you can put any input topic and you provide any sources on the internet in which you can actually learn that topic, and pathways in which you could potentially increase your experience level, your level of understanding in the topic. And this is basically one of the examples of using artificial intelligence. This would be like a machine learning model to dig the internet in order to find the sources that are most reliable in order to learn literally anything. Now, does that replace the job of educators? In my opinion, that is an absolutely not answer. Because educators are still the number one source of that personalization and understanding of where each individual is going to be and what they need in order to learn what they need to do. Machine learning, artificial intelligence is not at the point yet, and I don't think it would ever be a replacement to the educators that are in the industry. What I do believe is that it can aid the role and the job that educators do, for instance, in this example of the learning phase or the curriculum building phase. In the learning phase, I think it is extremely important to recognize that there are different learning paths and each person may have different styles of learning. So when we built this website, we decided to provide video, to provide text, to provide audio, to provide example, to provide quizzes, and basically to give the person the options to learn anything as they wish to learn it, whether it's experiential or whether it's visual, auditory, and all that good stuff. And so that is part of what artificial intelligence can do, which is like match the learning style with the person and provide different ways in which the same topic can be taught to the person so that they actually will come to an agreement of basic understanding. And then the third part is the assessment part, like you were asking about, is like, how do you actually understand the topic that was taught and how do you test that? And artificial intelligence applies the same way in which it can personalize the way we can test the understanding of any topic and really recognize the individuality of the person in terms of learning something. Is there anything deeper than that, Desmond, that I can talk about?
That's actually amazing, because what we're hearing is that there's this pathway that we really, many of us, myself included, might not have really decided to dig into, which is how do we create a knowledge base, not just a knowledge base, but also different experiences, curricula that will address learning styles and do that in a massive, really robust way. Curriculum development and writing is something that's really close to my heart, and this idea of actually being able to test our students in different modalities. It's something that we're still really struggling with in many ways, especially now that we understand that your traditional A, B, C grade, or what you might score in a standardized test, is not a great reflector of your ability to problem solve amongst a team in data science or in robotics or in a drone industry. Getting away from the page and giving ourselves more resources to really tackle that becomes a very, very valuable resource to have. That's also that's a great perspective to have there.
Yeah, so, and there's definitely a level of automation, that can happen to the core curriculum, to something that is standardized across the industry versus the things that need to be specialized.
Absolutely. So we're running and having good conversations here. I want to focus a little bit more on students. We've been talking about the structure of industry and even what we've seen in the classroom so far, and kind of how we might change and flip our expectations into the future. I like to think about where our students are going to go from here and how we can really assist our students. So these questions are more simple, but they have the potential for much wider, broader answers. The first question is, how do we start to define a legitimate first step for students at the elementary and high school level when we think about artificial intelligence or just data science? What's a great starting point? And I'll piggyback a little bit on that for you, Marina. If you would be so willing, can you share what your starting point was?
Ah, my starting point. Oh my God. I think I don't know if I want to say unfortunately, but I think my need for discovering data science and artificial intelligence came from the fact that I am a super efficient person. And so I was like, anything that I have to repeatedly do, I do not want to do. Like if I have to enter this revenue number one more time for this VP, I'm gonna shoot myself. Like let me build a dashboard for them so they can go and figure it out on their. I don't have to tell you a number. You got it, right? Like you can read. So like it really came from the fact of probably like I want to say laziness and being like, I don't want to do this again. Why do I have to do this again? Like it seems like it's the same job over and over and over. And so that's really honestly part of like what artificial intelligence is really automating those things that are very repeatable. And let me say that in addition to the definition that Desmond gave you earlier, if you want to think about a simple way of artificial intelligence, is you start with an if and then condition. And so you start to say, if if it's 7 a.m., then coffee made, right? And artificial intelligence, all it does, instead of just setting if you want like a static definition, it automates it for you so that it knows that if Marina wakes up, then coffee, right? So it's not anymore like a specific time, is when Marina wakes up, then she wants the coffee, let me make that coffee for you. So that's the simpler level of artificial intelligence. Now, how do we start defining that for students? I think it's like the things that I would do first is like getting them really excited about something, right? I still remember some of the robotics class that I took where we built a car or we built a Roomba on the computer and we had to go clean a fake virtual apartment with the Roomba. And we have to figure out how do we program a Roomba in order to clean the whole apartment. And that's kind of like what really, one of the examples that really got me excited. So finding a way to get students excited about this type of stuff is really what I would like to think about it. And that's really how it started for me as well. And obviously you all know that at different level of age and education and circumstances, you'll have different students that will be excited about different things, and making it extremely relevant for them could be really a real thing. Like getting into Instagram and figuring out how do you use artificial intelligence within Instagram to make a better to increase your likes or whatever it is, right? So make it so that it's super relevant for them and they can figure out something that is going to make their life a little bit easier and a little bit better. But if I had to also say at the most basic level, AI is nothing but math. So to me, it's super important to make sure that everybody's excited about math in some way, shape, or form, and or at least know the basics of what everybody needs to know about math.
Awesome. We deeply believe in the importance of robust math education here at NextWaveSTEM. And when you talked about Instagram, for example, and how we can engage our students at that level where they're really excited about these social media platforms and really excited about engaging in a globalized world in a more robust way, where society isn't just relegated to their immediate cohort that's physically around them, but to the world. That enters into this really interesting question, if we go forward instead of backward, about the way that students will need to navigate a new political spectrum. There are amazing examples and horrifying examples of the way that artificial intelligence and algorithm manipulation change real physical borders, change real political borders, and have these consequences In many ways, it's important for us now to think about ourselves and our students, just not as global physical citizens, but also digital citizens. So the big question, and we're getting deeper and deeper as we ask these questions, thinking about our student engagement, is how should we expect students to engage with artificial intelligence generally, but even ideas of data as informed digital citizens? How do they build themselves into those citizens for the future?
Yeah, like anything, I feel like the more you know about something, the least black box becomes. And so even when I hear, congressmen or people from the House inquire about the actions of the big techs, they're still quite uninformed in their questions. And I wish, like you're saying, like we all could engage as more informed digital citizens and ask better questions, because we could get to deeper answers. One of the things that I would say, though, as I answer this question, is that artificial intelligence is not as smart as some people may make believe it is. It is just as smart as humans are. And so that means that anybody could understand beyond like the artificial intelligence components and how they interact in order to provide a results. The reason why it's so flawed is because our thinking as humans is flawed, and those flaws reflect in our work within artificial intelligence. Unfortunately, it does not correct itself, and it does not correct the bias that we program into artificial intelligence. So that's why we have to be hyper aware of AI and hyper aware that we need diversity of thinking, of experiences, and of informed citizens within AI in order to make sure that we don't make those mistakes over and over again. There's a big problem with the population of current, AI programmers of being predominantly white male, and those biases that are within that population will reflect the technologies that are built. And one of my jobs in life is going to be to make sure that we have more women, specifically within AI, so that we can have a better diversification of thought and less discrimination within AI towards women. And there's other works within, ethnical sources that needs to happen as well. So we need to engage all of our students. I guess that's what I'm saying, in order to create one better AI, right? The other thing is we need to understand it in order to challenge it and in order to create it, make it better. The way, again, I think of students interacting with AI is the same way I was talking about it a little bit earlier. As there's going to be the builders of AI, and there's going to be the users and the people that apply AI. That's a simple way of kind of categorizing, the different roles within AI. The people that are going to build the AI, the programmers, the data scientists, the developers, those will need to engage, like learn how to build that, and therefore, probably have extensive more education than those that interact within engineering and computer science and data science, than those that interact with AI. Those that interact with AI will need to understand it, but not necessarily go as deep as those that actually build it.
That makes sense, to think about the kind of the difference in the education level as we are dealing with a much more robust technical background. The idea that the AI that we build and that impacts our lives reflects our own biases is something that you're absolutely right, we don't consider enough. It is the kind of thing that I think that our students, if we're not being critical, our professionals, our legal representation, our representatives in Congress at the local, state, and national level, we don't have very many scientists in those ranks who understand the depth of the work that's being done. So this idea of being hyper aware of AI, and even the broader scope where many of our engineers, many of our product designers, even our product managers who are building these tools, how good of a job do we do of communicating that and creating an informed citizenry? Is that our role? Those questions are sticky and amazing questions that our students will have to answer. That's an exciting prospect to see that becoming diversified, see it become less white and less male and reflect a world that actually exists. That is very exciting work that you're doing. And towards that end, I'm sorry, go right ahead.
Yeah, can I also say that, like, I would love to see more students taking apart a computer versus just using one. Like, it's definitely like super interesting to have a population of people, of, you know, the next generation of young people having the ability to interact with screens, but having no idea of how they work. And so you can see that even, like, I have 3 daughters, and I try really hard to make sure that they kind of have some type of basic understanding of why the phone, you can use your finger to use it to you know, go interact with your phone, but you cannot use your finger to touch the TV, because that does not work that way. And I think that's
Right.
something, a very relatable example of, like, things that they should know about, that perhaps they're not as aware because they just use it and move on.
Yes, that even that foundational understanding of technology and the world around us. Okay, there is a difference between this machine that has a capacitive screen and this one that doesn't. That's exciting to see. We're seeing more and more young ones touching their television screens. Okay, Marina, I'm going to turn you into a philosopher a little bit and just ask you the big overarching question here. The question that we will probably wrestle with in some form or another for the next 100, 200, 300 years. How will we define ethical AI usage? And the reason why I ask this is because you mentioned before, you talk about biases that can come out in our outputs and our data that have some reverberating, some positive feedback loops into other things that happen. And we even think about more and more of the ways that AI is going to be intertwined into our lives. Thinking about how many of those interactions that we might have had really repeated things happening in the financial sector, or even in law enforcement, or in cybersecurity. How many of those things that had a human touch will no longer have a direct human touch, will have AI that are informed by our human biases. How do we say to our students, this is the right thing to do with artificial intelligence, and this is the wrong thing to do with artificial intelligence?
Right off the bat,
big question, I know.
Yeah, right off the bat, we have a saying within, well, at least I tell this to all of my teams, is just because we can do it doesn't mean that we should do it. And that's definitely a tough question that we ask in every single feature. Feature is basically a new solution that we put out. For every single feature that we put out, we ask ourselves the question: 1, can we do it? Yes. 2, should we do it? And whatever, that should is defined differently, obviously, for different organizations, but should we do it is always the second most important question. I don't have the answer to this question, but I do have an example, a story, I guess, a couple of stories. Engineering in general is the only engineering that is non-regulated by the government. And most of the industry is hyper aware of this. As engineers, software engineers, AI engineers, data engineers, we know that we could be regulated and we are not. And so long time ago, the industry has decided to create some type of self-regulation. Now, it has gone, in some example, extremely bad. We know that Tesla has caused multiple deaths. The AI of Tesla has killed people. On the other extreme, we know that the AI of some social networks have helped millions of people create reforms in their governments, save lives, and address injustices in the world. The ethics around AI, I think, are going to be moving with the ethics of the human consciousness as we move forward. I think that's the best I can tell you.
And that is a fair answer.
Hopefully our future generations are going to have morals and standards that are way better than our generations, and they will define those within the technologies they built.
That is a really, really fair answer. It's a difficult question and something that we wrestle with at NextWaveSTEM, because we're teaching emerging technology, is to also wrestle with the impacts in the past of technologies that might have emerged. If we think about in Industry 3.0 and what that meant for globalization, for the invention of the automobile, for the invention of the railroad, for the eventual invention of a global network that allows the internet to happen, that allows for the Zoom call to even happen. Life-changing, global life-changing, changed our reality, but we're also dealing with the outcome of that, the unintended consequence that is climate change, for example. It is really, really useful that as engineers of all stripes, we continue to teach our young people about not just solving the problem for our end user and our client. And just like you said, wrestling with the idea of, okay, yes, we can do it, but should we? Digging into that question of, okay, what happens if I don't use this anymore? What happens after our client is done using it? What kind of trickle down effects we have? None of us can see the future. We're not there yet. Don't ask me if we're in a simulation. I don't have an opinion, so I can't run that clock forward to answer that
simulation.
But I have to say I agree with you that raising a next generation of ethical, kind, and gracious human beings will also help us save the world here. Our children will definitely save the world.
Ethics definitely remains with the humans and not with the machines.
Absolutely. Well, Marina, I definitely appreciate your time helping us today. We are running really close to the end here, so I will speak briefly about what NextWaveSTEM can do to help you as you continue to build AI programs for your students, as you continue to invest in those pathways that lead to these degrees, not just degrees, but to these jobs, and to these non-traditional roles that might not even require a traditional college degree. At NextWaveSTEM, we offer standards line courses, next generation science and 21st century skills, K through 12 in our 3 technology tracks. In our high school level, the 9 through 12, we offer an introductory advanced machine learning and artificial intelligence course. It's a great place for your students to begin to think about ethics, thinking about the different ways in which AIs are being used around them every day, but will be used in the future. When we think about our courses, there's progression and knowledge that really follows Bloom's taxonomy. If you're K through 2 and this is your first time experiencing technology, or if you're in high school and you're really needing to evaluate and develop solutions for real world problems, our products have you covered. And working with NextWaveSTEM, you also have an all-in-one solution, not just a lesson plan, not just supporting materials, but also equipment that you need, access to our learning management system, hands-on training, and help with implementation, and we can customize for your particular need as well. We did have a cool Q&A question or prompt to get our minds thinking a little bit. However, we are out of time. For those of you who would love to answer this question, throw it in the chat right now with a couple of moments that we have left. Really would love to know, what kind of solutions would you want from an artificial intelligence and why? If you could think of an algorithm that could do something for you, and Ellen, you said laundry, totally laundry. Yes, I have a really nice calculation for how long it takes me to do the laundry. Well, we recently moved, so it got much better. But any solutions that you could think of, we would love to learn more about them. Um, but in in addition to sharing your solutions with us, you can just email me. My my email is really simple, and I'll show it to you in a second. We would love for you also to connect with the Unbossed podcast, available on Spotify, Apple Podcasts, Google Podcasts, and pretty much any place that you can get your podcast. Marina is interviewing women in tech all throughout the Chicagoland area. She's interviewed over a dozen CTOs in Chicago tech companies, and she's going to be continuing to do this good work of thinking about ways in which women are continuing to press technology forward. Marina, did you want to talk a little bit more about Unbossed?
Yeah, UNBOSSED is basically I have a 1 hour fun conversation with a bunch of badass women in Chicago. And I am expanding my audience to not only CTOs, which is Chief Technology Officers, but also with CEOs, Chief Executive Officers of technology companies, as well as women in politics.
Awesome. Thank you so much, Marina. You'll be getting the link as we share out the webinar slide deck, as well as the recording today, a link to subscribe. I have, and it's really, really cool. But if you want to reach out to us, there are a couple easy ways. My email, super simple, Desmond@nextwavestem.com. I love getting into the weeds. I love talking about programs. I love connecting people to our school partnerships manager. If you're interested in learning more, you can find Marina at her website, marinamalaguti.info, to learn more about UNBOSSED and the work that she's doing as a coach. NextWaveSTEM can also be found at NextWaveSTEM on all major social media platforms, Twitter, Instagram, LinkedIn, and Facebook. We do not tick, we do not talk, not yet at least. That algorithm has not captured our data in that specific way, but that's something that we may assign an intern to in the near future. With that being said, I want to thank each and every one of you so much for your time with us today. I want to thank Marina once again for joining us. Marina, we're going to give you the last word. Is there anything that you want to leave with our participants?
I would say y'all can also do technology as well as not only for the students.
Awesome. You all can also do technology. Believe it. We're wishing you all to be safe, stay healthy. If you're in the Chicagoland area, enjoy the weather as it continues to break. And we will check you out on the next one. Bye-bye, everyone.